Welcome to Math with Mr. J. In this video, we're going to go through a complete step-by-step fractions course. We'll start with a fraction vocabulary review, move on to fractions on a number line, then we will take a look at equivalent fractions. Next, we have simplifying fractions, then comparing and ordering fractions. Then we'll move on to converting between mixed numbers and improper fractions. And we will end with adding, subtracting, multiplying, and dividing fractions. Everything has been time-stamped and put into chapters, so feel free to jump around to the topics you need. Let's get started. Let's jump into our fraction vocabulary crash course here, our fraction vocabulary review. We'll go through everything you see on your screen. Now this will be a quick review. It's going to be a refresher, and then we will go into more detail throughout the video. Let's get started. So jumping into our first words here, we have numerator, fraction bar, and denominator. These are the parts of a fraction. The numerator is the top number and represents the number of parts being considered, or we can think of it as the number of parts we are focused on. Then we have the fraction bar, which separates the numerator and denominator. Then the denominator is the bottom number and represents the total number of equal parts a whole has been divided into. And we can think down to remember denominator, so match the D's. And then if we remember what the denominator is, then we know the numerator will be the top. Now let's use the fraction 3/8 for an example here. We have the numerator, the fraction bar, and the denominator. Let's use a simple example for this fraction to take this a step further. We'll say that 3/8 of a whole pizza is left. 8, the denominator, is the total number of equal parts, or pieces, the pizza was divided into. And the numerator, 3, those are the parts, or pieces, left. That's the part of the pizza being considered, or that we are focused on. So numerator, fraction bar, denominator. Let's move on. Now let's take a look at proper fraction. These are fractions where the numerator is less than the denominator, so the top is less than the bottom. The value of a proper fraction is less than 1 whole. 1/4, 2/5, and 9/10 are all examples of proper fractions. Let's move on to improper fractions. These are fractions where the numerator is greater than or equal to the denominator. So the top is greater than or equal to the bottom. The value of an improper fraction is 1 or more. 7/3, 15/8, and 4/4 are all examples of improper fractions. Now keep in mind, 4/4 is equal to 1. Remember, if the numerator and denominator are the same, that fraction is equal to 1. Then we have mixed number. That's just a whole number and a fraction. For example, 2.5, 6 3/4, and 12 7/10. Those are all examples of mixed numbers. We have that whole number and fraction. Let's move on. Now let's take a look at equivalent fractions. Equivalent fractions are different fractions, so the numerators and denominators are different, but they represent the same value. For example, let's use a fraction that we are all familiar with, 1/2. 2/4 is equivalent. 2/4, that's still half. 10/20 is also equivalent. All of these fractions are equivalent. They may look different, but they all represent the same value. And then one more example here. 3/4 and 6/8 are equivalent fractions. Let's move on to simplest form, lowest terms, or reduced. So whenever we hear simplify a fraction, put a fraction in lowest terms, or reduce a fraction, they all mean the same thing. So something to keep in mind. I typically use simplify, but the others are common as well. Now, basically, when we simplify, put a fraction in lowest terms, or reduce a fraction, we rewrite that fraction as an equivalent fraction where the numerator and denominator are the smallest whole numbers possible. The only common factor between the numerator and denominator is 1, so we cannot break the fraction down any further. Now, it's important to understand we do not change the value of a fraction when we simplify. For example, let's use something to go along with 1/2 again. Let's do 5/10. We can simplify this fraction by dividing the numerator and denominator by the common factor of 5, meaning we need to divide 5 by 5 and 10 by 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. The only common factor between 1 and 2 is 1. So this is now in simplest form. Another example, let me squeeze it in down here. 16/24. One way to simplify this, we have a common factor of 8 we can divide both by. So let's divide 16 by 8 and 24 by 8. 16 divided by 8 gives us 2, and 24 divided by 8 gives us 3. The only common factor between 2 and 3 is 1, so this is now simplified. 16/24 simplifies to 2/3. Moving on to common denominator and least common denominator now, let's focus on common denominator first. And a common denominator is just a shared denominator. So a shared denominator between two or more fractions. The same denominator. So for example, 1/4 and 3/4 have a common denominator of 4. Now do 2/5 and 5/8 have a common denominator? No, clearly 5 and 8 are not the same. So those two fractions do not have a common denominator as is. Now please keep in mind, when working with fractions, we may not start with a common denominator, but we can always find one. For example, when we add or subtract fractions, we need a common denominator. So we find one and then rename the fractions with that common denominator. Now, when we find common denominators, there will be an infinite amount. So it's helpful and makes things simpler to use the least common denominator. So when we hear least common denominator, or LCD for short, that just means the smallest common denominator. We will build off of this and go into more detail in other videos. For now, we just need to remember that a common denominator is a shared denominator, the same denominator. And least common denominator means the smallest common denominator out of all the possibilities. Now let's jump into like fractions. Like fractions are just fractions with the same denominator. So for example, we would say that 3/10 and 7/10 are like fractions. Unlike fractions are fractions with different denominators. So 5/6 and 1/2 are unlike fractions. So to go off of this, for example, if we hear adding fractions with like denominators, we know that we are adding fractions with the same denominator. And then if we hear adding fractions with unlike denominators, that means we are adding fractions with different denominators. Next, we have reciprocal. And to find the reciprocal, that just means to flip a fraction. So the numerator becomes the denominator and the denominator becomes the numerator. We use reciprocals when dividing fractions. So for example here, the reciprocal of 3/4, we need to flip this fraction. So 3 is now the denominator, and 4 is now the numerator. So the reciprocal of 3/4 is 4/3. Now, any number multiplied by its reciprocal equals 1. So let's do 3/4 times its reciprocal of 4/3, just to see what this looks like. Now, when we multiply fractions, we multiply straight across. So for the numerators, 3 times 4 is 12. And then for the denominators, 4 times 3 is 12. So we end up with 12/12, which is 1. Remember, like we mentioned earlier, whenever we have the same numerator and denominator, that fraction is equal to 1. So for reciprocal, just remember, that means to flip a fraction. Let's move on. Now let's take a look at factor, common factor, and greatest common factor. We'll start with just factor. Now, factors are numbers that a given number can be divided by evenly, so no remainder. We can also think of factors as all of the numbers that go into a number evenly. For example, the factors of 6 are 1, 2, 3, and 6. We can divide 6 by all of those numbers without getting a remainder. In other words, all of those numbers go into 6 evenly. Now let's take a look at the factors of 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. So looking at the factors of 6 and 12, let's move over to common factors now, which are just factors that numbers share. So between 6 and 12, 1 is a common factor, 2 is a common factor, 3 is a common factor, and 6 is a common factor. So again, common factors are just factors that numbers share. Then as far as the greatest common factor, that's the greatest or biggest factor in value that the numbers share. That's going to be 6 here. The greatest common factor between 6 and 12 is 6. Now you'll also hear greatest common factor called the GCF for short. We use factors, common factors, and greatest common factor when working with fractions. For example, when simplifying fractions. Let's move on to multiple, common multiple, and least common multiple. We'll start with multiple. Now, multiples are the result of multiplying a number by a whole number. And we can think of skip counting here. So for example, some multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, and these continue on forever. Multiples are infinite, so we will stop there. So we have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, so on and so forth. And we can just skip count here by 3's to get our multiples of 3. Now, technically, we can multiply by any integer, which means we could include negative multiples. So -3, -6, -9, and so on. But when we list multiples, we usually just want the positive ones. So something to keep in mind. Now let's take a look at some multiples of 4. So 4, 8, 12, 16, 20, 24, 28, 32, and so on. Now let's move on to common multiples. Those are all of the multiples that numbers share. Since multiples continue on forever, they're infinite, that means common multiples end up being infinite as well. So looking at the lists of multiples we have, do we have any common multiples? Yes. 12 is a common multiple, and 24 is a common multiple. Now, if we were to continue those lists, we will continue to find common multiples. Now, least common multiple is the least or smallest multiple in value that the numbers share. The least common multiple between 3 and 4 is 12. We use multiples, common multiples, and least common multiples when working with fractions. For example, when finding a common denominator. So there's our fraction vocabulary crash course. Let's move on to our next section, fractions on a number line. Here's our section on fractions on number lines. We'll go through how to plot fractions on number lines, that's numbers 1 through 4, and how to identify fractions on number lines, that's numbers 5 through 8. This will give us a strong foundation for understanding fractions on number lines and fractions overall. Let's jump into number 1, where we have 3/5. Now, 3/5 is a proper fraction. Its value is less than 1. So we have a number line showing 0 and 1. 3/5 is somewhere in between. Now notice 1 is divided into 1, 2, 3, 4, 5 equal parts, so fifths. So each part is 1/5 of the whole. Now going from 0 and working our way right, this is 1/5, 2/5, 3/5, 4/5, and then 5/5 is 1. So we plot 3/5 right here. Let's move on to number 2, where we have 7/8. So again, a proper fraction here. So this will be between 0 and 1. And 1 whole was divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So eighths. And going from 0, we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8 is 1. So 7/8 is right here. Moving on to number 3, we have 1 and 2/3, which is a mixed number. We have 1 whole and then a fraction. That means we are greater than 1 here, but less than 2. 1 and 2/3 is going to be in between 1 and 2. Now, in between here, we have 1, 2, 3 equal parts, so thirds. This is going to be 1 and 1/3, and this is going to be 1 and 2/3. Then comes 1 and 3/3, which is 2, because we have 1, and then 3/3 is 1 as well, so that gives us 2. So 1 and 2/3 is right here. So when it comes to mixed numbers, we just have to figure out which 2 whole numbers the mixed number is in between. And then we use the fractional part to find exactly where the mixed number is on the number line. Let's try another mixed number and move on to number 4. We have 3 and 1/4. This is greater than 3, but less than 4. So this is going to be in between 3 and 4. We have 1, 2, 3, 4 equal parts in between 3 and 4. So fourths. This is 3 and 1/4, 3 and 2/4, 3 and 3/4, and then 3 and 4/4. That's 3 and 1 whole, so that brings us to 4. So 3 and 1/4 is right here. So there's how to plot fractions on a number line. Let's move on to identifying fractions on a number line and take a look at number 5. Now notice our point is in between 0 and 1, so it's less than 1 whole. And then 1 whole is divided into 1, 2, 3, 4 equal parts, so fourths. This is going to be 1/4, 2/4, and 3/4. Then 4/4 is 1 whole. So our fraction here is 3/4. Let's move on to number 6, where it looks like we're going to have a mixed number. We can see that our point is in between 5 and 6. So this is greater than 5, but less than 6. That tells us our whole number is 5 here. Now we need the fractional part. Well, we have 1, 2 equal parts, so halves. This is 5 and 1/2 here. So our fraction, 5 and a half. Moving on to number 7, we have a fraction in between 0 and 1. So this is going to be a proper fraction. This is less than 1 whole. 1 is divided into 1, 2, 3, 4, 5, 6 equal parts. So we have 1/6, 2/6, 3/6, 4/6, and 5/6. Then 6/6 is 1 whole. So our fraction here is 1/6. Lastly, for number 8, we have another mixed number. This mixed number is in between 9 and 10. So greater than 9 and less than 10. We have 9, and then we need our fractional part. Well, we have 1, 2, 3, 4, 5 equal parts, so fifths. So this is 9 and 1/5. I don't have enough room to write the whole number as well, so I'll just put the fraction. So that's 9 and 1/5, 9 and 2/5, 9 and 3/5, 9 and 4/5, and then 9 and 5/5. Well, we have 9 and then 5/5 is 1 whole, so that is 10. So our fraction here is 9 and 4/5. So there you have it. There's how to plot and identify fractions on a number line. Let's move on to equivalent fractions. Here's our section on equivalent fractions. Now, equivalent fractions are fractions with different numerators and denominators, but they represent the same value. In other words, they are fractions that look different, but they have the same value. Now, when finding equivalent fractions, we can either use multiplication or division, as long as we do the same thing to both the numerator and denominator, the top and bottom. Let's take a look at multiplication first and jump into number 1, where we have 1/2, a fraction we are all familiar with. Let's write some equivalent fractions using multiplication. And we do this by multiplying the numerator and denominator by the same number. For example, let's multiply the numerator and denominator by 2. 1 times 2 gives us 2, and 2 times 2 gives us 4. We get 2/4. 1/2 and 2/4 are equivalent fractions. Let's try multiplying by 7 to get an equivalent fraction. So we need to multiply the numerator by 7 and the denominator by 7. 1 times 7 gives us 7, and 2 times 7 gives us 14. So we get 7/14, and these are equivalent fractions. How about multiplying by 50? So 1/2, and we multiply the numerator by 50 and the denominator by 50. 1 times 50 is 50. 2 times 50 is 100. So we get 50 hundredths. 1/2 and 50 hundredths are equivalent fractions. Now we can actually find an infinite amount of equivalent fractions when multiplying. As long as we multiply both the numerator and denominator by the same number, we end up with an equivalent fraction. Let's move on to number 2, where we have division. our fraction is 9/12. Now for division, we don't have as many options as we do when we use multiplication. And for some fractions, division isn't an option at all. This is because we need to have a common factor between the numerator and denominator, a number that we can divide by without getting a remainder. So we need to find a number that we can divide both our numerator and denominator by other than 1. So do we have a number that we can divide both 9 and 12 by without getting a remainder? Yes, 3. So we can divide both 9 and 12 by 3. And that will give us an equivalent fraction here. 9 divided by 3 gives us 3. And 12 divided by 3 gives us 4. So 9/12 and 3/4 are equivalent fractions. Now to go off of this, please keep in mind for a fraction like 3/4, we can't use division. The only common factor, the only number we can divide by for both 3 and 4 is 1. And think about it. If we divide both 3 and 4 by 1, we just get 3/4 again. So when we can't divide by anything other than 1, the only common factor is 1. This is what we call a fraction in simplest form. Let's move on to number 3, where we will use multiplication and division. So we will find two different equivalent fractions. We have 10/25 for our fraction. Let's start with multiplication, and we will multiply the numerator and denominator by 3. 10 times 3 gives us 30, and 25 times 3 gives us 75. So we get 30/75. And these are equivalent fractions. Now let's use division. So we need to think of a common factor between 10 and 25, something we can divide 10 and 25 by. Well, 5. Let's divide 10 by 5 and 25 by 5. 10 divided by 5 gives us 2, and 25 divided by 5 gives us 5. So we end up with 2/5. These are equivalent fractions. Let's move on to numbers 4, 5, and 6, where we are given part of an equivalent fraction, and we need to find the missing number. We will start with number 4, where we have 5/6 equals what over 24. So we need to figure out our missing numerator here. Well, we need to use what we know about equivalent fractions to figure this out. We can either use multiplication or division, and whatever we do to the numerator, we must do to the denominator. Or vice versa, whatever we do to the denominator, we must do to the numerator. Now we have 6 and 24 for our denominators, so we know our denominators here. How do we go from 6 to 24? How do we get 6 to equal 24? Using multiplication or division. Well, 6 times 4 gives us 24. Whatever we do to the denominator there, we must do to the numerator in order to keep this equivalent. So we need to multiply 5 by 4 as well. 5 times 4 gives us 20. So our missing numerator is 20. 5/6 and 20/24 are equivalent fractions. Let's move on to number 5, where we have 9/27 equals what over 3? So how many thirds? Well, we have both denominators here. We have 27 and 3. So we need to think, how do we go from 27 to 3? How do we get 27 to equal 3 using multiplication or division? Well, 27 divided by 9 equals 3. Whatever we do to the denominator, we must do to the numerator. So divide the numerator by 9 as well. 9 divided by 9 gives us a numerator of 1. So we get 1/3. 9/27 and 1/3 are equivalent fractions. Lastly, for number 6, we have 8/14 equals 4 over what? So we have a missing denominator here. We have both numerators, so let's go off of those. So 8 and 4. How do we get 8 to equal 4 using multiplication or division? Well, 8 divided by 2 gives us 4. Whatever we do to the numerator, we must do to the denominator in order to keep this equivalent. So we have 14 divided by 2, and that will give us our denominator. 14 divided by 2 gives us 7. So we end up with 4/7. 8/14 and 4/7 are equivalent fractions. So there's our section on equivalent fractions. Let's move on to simplifying fractions. Here's our section on simplifying fractions. Now, when we simplify fractions, we're looking to get the smallest numbers in value that we possibly can, the simplest numbers for our numerator and denominator. We do this by finding common factors between our numerator and denominator. And factors are numbers that we can divide our numerator and denominator by without getting a remainder. Once the only common factor is 1, the fraction is in simplest form. Basically, that means we can't break the fraction down any further. So when we're simplifying fractions, we need to be thinking, is there anything we can divide the numerator and denominator by? Let's jump into our examples, starting with number 1, where we have 8/12. And for number 1 here, we're really going to break this down and write out each step. We'll start by writing out the factors of 8 and 12. And we'll do this off to the side. Now, this can be helpful when simplifying, but we do want to get to a point where we can simplify without writing out all of the factors. Let's start with the factors of 8. And for factors, we need to think about all of the numbers that we can multiply together to equal 8, or think all of the numbers we can divide 8 by without getting a remainder. We can also think of this as all of the numbers that go into 8, so to speak. We will start with 1 and 8. We can always start with 1 and the number itself. 1 times 8 equals 8, or we can think in terms of division. We can divide 8 by both 1 and 8. Now I left a gap in between for any other factors. 2 and 4 are also factors of 8. So 2 and 4. And those are all of the factors of 8. 1, 2, 4, and 8. Now for 12, we will start with 1 and 12. And we have our gap there to fill with any other factors. Well, 2 and 6 are factors of 12. 2 times 6 equals 12. Or we can think in terms of division. We can divide 12 by 2 and 6. So 2 and 6 are factors. 3 and 4 are also factors. So 3 and 4. And those are all of the factors of 12. 1, 2, 3, 4, 6, and 12. Now we're going to use the greatest common factor between 8 and 12 here. That way we can simplify this in one step. The greatest common factor is 4. That's the largest factor they share. Now we take that greatest common factor of 4 and divide our numerator, 8, and our denominator, 12, by 4. 8 divided by 4 gives us 2, and 12 divided by 4 gives us 3. So we end up with 2/3. The only common factor between 2 and 3 is 1. So this is in simplest form, and we are done. So 8/12 in simplest form is 2/3. Now please keep in mind, a simplified fraction is equivalent to the original fraction. We're not changing the value of the fraction at all when we simplify. Now, before moving on, I do want to cover one more really important thing here about simplifying. When we simplify, there may be multiple paths, multiple ways that we can simplify. So for example, let's say we divided 8 and 12 by the common factor of 2. So let's write this out, 8/12. And let's say again that we divided by that common factor of 2. So 8 divided by 2 and 12 divided by 2. 8 divided by 2 gives us 4, and 12 divided by 2 gives us 6. So we end up with 4/6, which is different than our simplified fraction of 2/3. Well, we're actually not done simplifying here. 4 and 6 have a common factor of 2 that we can divide by in order to continue simplifying here. So we need to divide 4 by 2 and 6 by 2. 4 divided by 2 gives us 2, and 6 divided by 2 gives us 3. So we do end up with 2/3 that way as well. Either path works and got us to that simplified fraction of 2/3. If we use the greatest common factor between our numerator and denominator, then we will simplify in one step. If we use a factor less than the greatest common factor, then it will take more than one step. So something to keep in mind. Let's move on to our next examples. Taking a look at numbers 2 through 5, we're going to simplify these without writing out factor lists. Just remember, we're looking for common factors that we can divide our numerator and denominator by. For number 2, we have 25/40. Are there any common factors between 25 and 40 other than 1? Yes, 5 is a common factor. We can divide both 25 and 40 by 5. And 5 is actually the greatest common factor. So we can simplify in one step here by dividing our numerator and denominator by 5. So 25 divided by 5 and 40 divided by 5. 25 divided by 5 gives us 5, and 40 divided by 5 gives us 8, and we end up with 5/8. The only common factor between 5 and 8 is 1, so we are done. 5/8 is our simplified fraction. Moving on to number 3, we have 18/24. Do we have any common factors between 18 and 24 other than 1? Well, our numerator and denominator are both even, so we can use 2 to start breaking this fraction down. But let's see if we can think of anything greater than 2. Well, I know that we can divide 18 by 3. I also know that we can divide 18 by 6 and 9. So will any of those work for 24? Yes, both 3 and 6 are factors of 24 as well. So let's use that greatest common factor of 6 and divide both 18 and 24 by 6. 18 divided by 6 gives us 3, and 24 divided by 6 gives us 4. So we end up with 3/4. The only common factor between 3 and 4 is 1, so this is now simplified. Now let's actually do number 3 again and take a different path. Let's start with the common factor of 2. So let's rewrite this and try simplifying by starting with that common factor of 2. 18 divided by 2 gives us 9, and 24 divided by 2 gives us 12. So we end up with 9/12, which is different than 3/4. But we have a common factor other than 1 that we can divide by here. We are not simplified yet. So what's that common factor other than 1? Well, 3. We can divide 9 by 3 and 12 by 3. 9 divided by 3 gives us 3, and 12 divided by 3 gives us 4. So we end up with 3/4 that way as well. And just to show one more path here, maybe you thought, well, 3 is a common factor. Let's start with dividing by 3 and see what happens. 18 divided by 3 gives us 6. 24 divided by 3 gives us 8. So we end up with 6/8. But we can continue simplifying here. We have a common factor of 2 that we can divide by. So divide 6 and 8 by 2. 6 divided by 2 gives us 3, and 8 divided by 2 gives us 4. So we get 3/4 that way as well. So a few different paths there to get to that simplified fraction of 3/4. Moving on to number 4, we have 10/60. So do we have any common factors that we can divide our numerator and denominator by other than 1? Yes, we do have some common factors here. They're both even, so 2 is a common factor. 5 is also a common factor. But our greatest common factor here is 10. So we need to do 10 divided by 10 and 60 divided by 10. 10 divided by 10 gives us 1, and 60 divided by 10 gives us 6. So we end up with 1/6. The only common factor between 1 and 6 is 1, so we are done here. This is simplified. Lastly, let's move on to number 5, where we have 14/35. So are there any common factors here other than 1 that we can divide by? Let's think about 14. We know that 1 and 14 are factors, but also we have 2 and 7. So do any of those factors work for 35 as well? Yes, 7. 7 is a common factor, and it happens to be the greatest common factor. So let's divide both 14 and 35 by 7. 14 divided by 7 gives us 2, and 35 divided by 7 gives us 5. So we end up with 2/5. The only common factor between 2 and 5 is 1, so we are done. So there's how to simplify fractions. Let's move on to comparing and ordering fractions. Here's our section on comparing and ordering fractions. We will start with comparing and then move on to ordering. Let's jump into number 1, where we have 1/4 and 3/10. So reading this from left to right, 1/4 is greater than, less than, or equal to 3/10. Now, the first thing that we want to do when comparing is see if we have a common denominator between the fractions. If yes, the fractions do have a common denominator, then just compare the numerators. Now, if we don't have a common denominator, we need to find one and rewrite or rename the fractions with that common denominator. Then we can compare the numerators. So for number 1, our denominators are 4 and 10. The least common denominator for 4 and 10 is 20. So let's rename these fractions with that denominator of 20. Let's start with 1/4. So how do we get that denominator of 4 to equal 20? Well, 4 times 5 equals 20. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. 1 times 5 gives us a numerator of 5. So our renamed fraction with a denominator of 20 is 5/20. And remember, these are equivalent fractions, so we're not changing the value of anything here. Now let's do 3/10. So how do we get 10 to equal 20? Well, 10 times 2 gives us 20. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. 3 times 2 gives us a numerator of 6. So we get 6/20. 6/20 is greater than 5/20. So going back to our original fractions, that means 3/10 is greater. Reading this from left to right, 1/4 is less than 3/10. Now, before moving on to number 2, I do want to mention we used the least common denominator of 20 here. But if we were to use another common denominator, for example, 40, that will still give us the correct comparison. So if we happen to use a common denominator other than the least common denominator, we will still be able to compare the fractions as long as we rename correctly. Let's move on to number 2, where we have 7/12 and 5/8. So we need a common denominator here. The least common denominator for 12 and 8 is 24. So let's rename these fractions with that denominator of 24. We'll start with 7/12. 12 times 2 gives us 24. So let's do that to the numerator, multiply by 2. 7 times 2 gives us 14. So our equivalent fraction with that denominator of 24 is 14/24. Now for 5/8. So how do we get 8 to equal 24? Well, 8 times 3 gives us 24. So we need to do that to the numerator as well. 5 times 3 gives us 15. So we get 15/24. Now 15/24 is greater than 14/24. So going back up to our original fractions, that means 5/8 is greater. So reading this from left to right, 7/12 is less than 5/8. Moving on to number 3, we have 1/2 and 5/14. Now for this one, we can actually think through which fraction is greater by using 1/2. Think about it. We know 1/2 is half. Looking at 5/14, let's think about what half of 14 is. Well, 7. So 7/14 is half. 5/14 is less than 7/14. That tells us 1/2 is greater. So 1/2 is greater than 5/14. Now let's prove this and write this out with a common denominator. The least common denominator for 2 and 14 is 14. Now 5/14 already has that common denominator, so let's rename 1/2 here. And we know that 2 times 7 gives us that denominator of 14. So let's do that to the numerator as well. 1 times 7 gives us a numerator of 7. 7/14 is greater than 5/14. So for some comparisons, we can tell which fraction is greater just by looking at the fractions and using what we know about fractions. Some comparisons are more obvious than others, and then some comparisons are very close. In this video, the comparisons are all pretty close, and nothing is too obvious. So we need common denominators to make sure we have the comparisons correct. So just something to keep in mind. Lastly, taking a look at number 4, we have 2/3 and 18/27. So we need a common denominator here. The least common denominator for 3 and 27 is 27. 18/27 already has that common denominator of 27. So let's rename 2/3. 3 times 9 gives us that denominator of 27. So let's multiply the numerator by 9 as well. 2 times 9 gives us 18. So we get 18/27. 18/27 is equal to 18/27. So reading our original comparison from left to right, 2/3 is equal to 18/27. So there's how to compare fractions. Let's move on to ordering. Here's our section on ordering fractions. Let's jump into number 1, where we need to order the fractions from least to greatest. Now, ordering fractions is just like comparing fractions. We need to rewrite or rename the fractions with a common denominator. Then we compare the numerators to put them in the correct order. Now for number 1, we're actually going to hold off on a common denominator for now and use a different strategy. We're going to order these fractions just by looking at them and using what we know about fractions. So we're going to think through this. For this, we're going to use 1/2. One of these fractions is greater than 1/2, one is less than 1/2, and one is equal to 1/2. So looking at the fractions, which is less than 1/2? Well, 3/10. Think, 5/10 is half, and 3/10 is less than 5/10. 3/10 is less than half. So 3/10 comes first. Again, that fraction is less than 1/2. Then we have 1/2, and that comes next. And then lastly, we have a fraction greater than 1/2, 4/5. So 4/5 is the greatest. And now we are in order just by thinking through this and using what we know about fractions. Now, will ordering fractions always be this straightforward and easy to think through? Will we always have something greater than 1/2, less than 1/2, and equal to 1/2? No, absolutely not. But I wanted to start here and mention this because this type of thought can be very helpful. Now, like I mentioned, putting fractions in order isn't always going to be this easy to think through, so we can't just depend on this strategy. But it is something important to keep in mind. Now let's actually prove we are in the correct order by renaming these fractions with a common denominator. The least common denominator between 5, 2, and 10 is 10. We will start by renaming 4/5. So how do we get that denominator of 5 to equal 10? Well, 5 times 2 gives us 10. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. 4 times 2 gives us a numerator of 8. Now let's rename 1/2. So we need that denominator of 10. 2 times 5 gives us 10. Whatever we do to the denominator, we must do to the numerator. 1 times 5 gives us a numerator of 5. And then 3/10 already has a denominator of 10, so we can leave that as is. And now we can clearly see that 3/10 is the least, so that comes first. And then 5/10 comes next, which the original fraction was 1/2. And then the greatest is 8/10, which the original fraction was 4/5. So here are our fractions in order from least to greatest. Let's move on to number 2, where we actually already have a common denominator of 8. And we need to put these in order from greatest to least. Now, we won't spend too much time on this one, but I did want to include an example with a common denominator. If we already have a common denominator, like number 2, all we need to do is compare the numerators in order to put them in order. The greatest is going to be 7/8, then 6/8, then 3/8, and then the least is going to be 1/8. So here are our fractions in order from greatest to least. Let's move on to numbers 3 and 4. Here are numbers 3 and 4, and these are going to be our tougher examples compared to numbers 1 and 2. For these, we don't have common denominators to start, and all of the fractions are pretty close in value. We can't just look at these and the order is obvious. For number 3, all of the fractions are less than 1/2. And for number 4, all of the fractions are greater than or equal to 1/2. So we're going to need to rename the fractions with common denominators. Let's start with number 3, where we have denominators of 5, 15, and 3. Now, I always like to find the largest denominator and see if it can be our least common denominator for all of the fractions. The largest denominator here is 15. And yes, this will work for our least common denominator. 15 works for 5, 15, and 3. So we need to rename with that denominator of 15. And we will start with 2/5 here. 5 times 3 gives us 15, so we need to multiply the numerator by 3 as well. 2 times 3 gives us 6. 4/15 already has a denominator of 15, so we do not need to rename. And then let's rename 1/3. 3 times 5 gives us 15, so let's multiply the numerator by 5. 1 times 5 gives us 5. Now with everything renamed with a common denominator, let's put these in order from least to greatest. We will use the original fractions here. 4/15 is the least, so that comes first. Then 5/15, which our original fraction was 1/3. So let's include 1/3 here. And then the greatest is 6/15, which the original fraction was 2/5. So let's include 2/5 here in our final list. And now we have our fractions in order from least to greatest. 4/15, 1/3, and then 2/5. Lastly, moving on to number 4, we need to order these fractions from greatest to least. We have denominators of 4, 12, 8, and 2. Our largest denominator here is 12. So let's work from that and find our least common denominator. So will 12 work for our least common denominator? Well, 12 will work for 4, 12, and 2, but it doesn't work for 8. So 12 is not going to be our least common denominator. Let's try the next multiple of 12, which is 24. Will 24 work for our least common denominator? Well, it works for 4, 12, 8, and 2. So yes, 24 is our least common denominator. So let's rename these fractions with that common denominator. And we'll start with 3/4. 4 times 6 gives us 24. So let's multiply the numerator. 3 times 6 gives us 18. Now for 7/12. 12 times 2 gives us 24. And then as far as the numerator, 7 times 2 gives us 14. And now for 5/8. 8 times 3 gives us 24. 5 times 3 gives us a numerator of 15. Now for 1/2. 2 times 12 gives us 24. And then for our numerator, 1 times 12 gives us 12. And now we have all of our fractions rewritten with that common denominator of 24. Now let's order these from greatest to least. The greatest is going to be 18/24, which the original fraction was 3/4. Next, we have 15/24, which the original fraction was 5/8. Then we have 14/24, the original fraction, 7/12, and then the least is going to be 12/24, which is 1/2. And now we are done. Our fractions are in order from greatest to least. Now, I do want to mention we used the least common denominators for the examples in this video. If we were to use another common denominator other than the least common denominator, this will still work. For example, if we used 30 for our common denominator for number 3, or 48 for our common denominator for number 4, those will still work. So something to keep in mind. So there's how to compare and order fractions. Let's move on to mixed numbers and improper fractions. Now let's take a look at converting between improper fractions and mixed numbers. So starting with improper fractions to mixed numbers, remember, an improper fraction is a fraction greater than or equal to 1. The numerator is greater than or equal to the denominator, so the top is greater than or equal to the bottom. Let's jump into number 1, where we have 13 over 2, 13 halves. We can see that we have an improper fraction here. The numerator is greater than the denominator. So we're going to write this as a mixed number. So we will have a whole number and a fractional part. We go from an improper fraction to a mixed number by dividing the numerator by the denominator. So the top divided by the bottom. So for number 1, we need to do 13 divided by 2. And we will write this off to the side here for number 1. So 13 divided by 2. So how many whole groups of 2 in 13? How many 2's in 13? Well, 6. That gets us to 12. So 6, this is our whole number of our mixed number. Now we multiply. 6 times 2 is 12. Then we subtract. 13 minus 12 is 1. So we have 6, remainder 1. We use that remainder of 1 for our fractional part of the mixed number. So 6 is our whole number, and then our remainder of 1 is the numerator of our fractional part. And then we keep the denominator the same. So we keep that denominator of 2. So 13 halves equals 6 and a half. We can always look to see if we can simplify that fractional part of our mixed number, but 1/2 is in simplest form, so we are done here. Again, 13 halves, 13 over 2, equals 6 and a half. So just keep in mind, all we need to do when going from an improper fraction to a mixed number is divide the numerator by the denominator. Let's move on to number 2, where we have 46 over 8. 46/8. Let's write this as a mixed number. So we need to do 46 divided by 8. How many whole groups of 8 in 46? How many 8's in 46? Well, 5. That gets us to 40. So 5 whole groups of 8. That gets us to 40. So we have a remainder of 6. That's our numerator. And then we keep our denominator of 8. So we end up with 5 and 6/8. Now 6/8 can be simplified. We have a common factor of 2 that we can divide 6 and 8 by. So let's simplify here. We can divide 6 by 2 and 8 by 2. 6 divided by 2 is 3, and then 8 divided by 2 is 4. So this simplifies to 3/4, and we have 5 and 3/4 now, which is in simplest form. Now for number 2, we did this one without writing the division out off to the side. Either way will work, so use what works best for you. To show number 2 written out, we can do 46 divided by 8. So 46 divided by 8, how many groups of 8 in 46? 5. Multiply, 5 times 8 is 40. Subtract, 46 minus 40 is 6. So we get 5, remainder 6. 5 is our whole number. Then that remainder of 6 is our numerator. Then we keep that denominator of 8. So we end up with 5 and 6/8, which we were able to simplify, and we ended up with 5 and 3/4. Let's move on to number 3, where we have 35 over 5, 35/5. So we need to divide. We need to do 35 divided by 5. Well, how many whole groups of 5 in 35? How many 5's in 35? 7. And that hits 35 exactly. So 7. And again, that hits 35 exactly. We do not have a remainder here. Since we don't have a remainder, we don't have a fractional part. We just have a whole number. And we are done. 35/5 equals 7. Again, we don't have a remainder. So this works out to be just a whole number. Lastly, let's move on to number 4, where we have 29 over 12. 29/12. So we need to write this as a mixed number. Let's divide. So 29 divided by 12. How many whole groups of 12 in 29? How many 12s in 29? Well, 2. That gets us to 24. So 2 whole groups of 12. That gets us to 24. So we have a remainder of 5. That's our numerator. And then we keep that denominator of 12 the same. So we end up with 2 and 5 twelfths. 5 twelfths is in simplest form, so we are done. 29 twelfths equals 2 and 5 twelfths. So there's how to write an improper fraction as a mixed number. Let's move on to writing a mixed number as an improper fraction. Here's our section on converting mixed numbers to improper fractions. Let's jump into number 1, where we have 2 and 4/5. So we need to write this mixed number as an improper fraction. All we need to do here is multiply and then add. We start at the bottom, multiply, then add. So we do 5 times 2 and then add 4. So again, we start at the bottom, and we multiply, then add. So we do 5 times 2, which is 10, plus 4 is 14. That's our numerator. Then we keep our denominator the same. So 5. That gives us our improper fraction. So 2 and 4/5 equals 14/5. Now, to break this down a little further and to explain how this works, what we basically do here, when we multiply, that gives us our whole number as a fraction with whatever denominator we have. For example, we did 5 times 2 here, and that gives us 10. And if we write that over our denominator of 5, we have 10/5. That's our whole number of 2 written as a fraction. 10/5 equals 2. Then we add the numerator, which is 4. So we have 10/5 plus 4/5. So we have our whole number as a fraction plus the fractional part of the mixed number. 10 plus 4 gives us 14. And we keep that denominator of 5 the same. So we get 14/5. So when we start at the bottom and multiply, then add, it's a quicker way to go through that process of writing the whole number as a fraction and adding the fractional part of the mixed number. Let's move on to number 2, where we have 4 and 1/4. So we need to multiply, then add. So multiply, then add. 4 times 4 is 16, plus 1 is 17. So that's our numerator. Then we keep that denominator of 4 the same. So 4 and 1/4 equals 17/4. Moving on to number 3, we have 10 and 5/8. So let's write this as an improper fraction. Multiply, then add. 8 times 10 is 80, plus 5 is 85. So 85 is our numerator. Then we keep that denominator of 8 the same. 10 and 5/8 equals 85/8. And then lastly, moving on to number 4, we have 7 and 2/3. Let's multiply, then add in order to convert this to an improper fraction. 3 times 7 is 21. Plus 2 is 23. 23 is our numerator, and then we keep that denominator of 3 the same. So 7 and 2/3 equals 23/3. So just remember, when we write mixed numbers as improper fractions, we start at the bottom and we multiply, then add. So there's how to convert mixed numbers and improper fractions. Let's move on to adding, subtracting, multiplying, and dividing. Now let's take a look at adding, subtracting, multiplying, and dividing fractions. We'll take a look at adding and subtracting first and go from there. We'll start with like denominators, so the same denominator, and then move on to unlike denominators, so different denominators. Let's jump into number 1, where we have 4/8 plus 3/8. We can see that we have like denominators here, that same denominator of 8. Now, whenever we are adding fractions and we have like denominators, all we need to do is add the numerators, the top numbers, and then we keep the denominator the same. That will give us our answer. And once we have that answer, we can look to simplify it if possible, if needed. So for number 1, let's start by adding those numerators. 4 plus 3 gives us 7. And then we keep that denominator of 8 the same. And we get 7/8. That's our answer. Now let's look to see if we can simplify 7/8. The only common factor between 7 and 8 is 1. So the only number that we can divide both 7 and 8 by is 1. That means we are in simplest form here, and we are done. So 4/8 plus 3/8 equals 7/8. Moving on to number 2, we have 13/15 plus 11/15. So we have that like denominator of 15, that same denominator of 15. And since we have like denominators, we can go ahead and add the numerators. 13 plus 11 gives us 24. And then we keep that denominator of 15 the same. So we end up with 24/15. Now this is an improper fraction. The numerator is greater than the denominator. We have more than one whole here. So let's convert this to a mixed number. Remember, we do that by dividing the numerator by the denominator, the top divided by the bottom. So 24 divided by 15. How many 15s in 24? Well, 1 whole 15. So that's our whole number of our mixed number. 1 whole 15 gets us to 15 out of that 24. So what's our remainder? What's left? Well, 9. That's the numerator of our fractional part of the mixed number. And then we keep that denominator of 15 the same. So we get 1 and 9/15, which this is correct. We have the correct mixed number here, but we can actually simplify the fractional part here. We have a greatest common factor of 3 that we can divide both 9 and 15 by. So let's divide 9 and 15 by 3 in order to simplify. We keep our whole number the same, so 1, and then we have 9 divided by 3. That gives us 3, and then 15 divided by 3 gives us 5. The only common factor between 3 and 5 is 1, so 3/5 is in simplest form. We are done. Our final simplified answer, 1 and 3/5. Now I do want to go back to how we converted 24/15 to 1 and 9/15. Again, we divided the numerator, 24, by 15. 24 divided by 15. Well, how many 15s in 24? Well, 1. And that 1 is our whole number of our mixed number. 1 times 15 is 15. 24 minus 15 gives us 9. So we get a remainder of 9. That remainder of 9 is the numerator of our fractional part of the mixed number. And then we keep that denominator of 15 the same. So there you have it. There's how to add fractions with like denominators. Let's move on to subtraction. Now let's take a look at subtraction. And this is just like addition, except we subtract the numerators. Let's jump into number 1, where we have 3/5 minus 1/5. So we can see here that we have like denominators, that same denominator of 5. So for number 1, let's start by subtracting those numerators. 3 minus 1 gives us 2, and then we keep that denominator of 5 the same. So we end up with 2/5. And that's our answer. Now, can we simplify 2/5? No. 2/5 is in simplest form. The only common factor between 2 and 5 is 1. So again, this is in simplest form. We are done. Our answer for number 1, 2/5. Let's move on to number 2, where we have 17/20 minus 12/20. So we have that like denominator of 20. That means we're able to subtract. So let's subtract those numerators. 17 minus 12 gives us 5. And then we keep that denominator of 20 the same. Now we are able to simplify 5/20. We have a common factor other than 1 that we can divide both 5 and 20 by. We can divide 5 and 20 by 5. That's our greatest common factor here. So let's divide 5 by 5 and 20 by 5. 5 divided by 5 gives us 1, and 20 divided by 5 gives us 4. The only common factor between 1 and 4 is 1, so this is now in simplest form. Our final simplified answer, 1/4. So there's our section on like denominators. Let's move on to unlike denominators. Now we're going to take a look at adding fractions with unlike denominators. Let's jump into number 1, where we have 2/5 plus 1/10. Now, when adding fractions, the first thing that we need to do is check the denominators. If they are the same, we can add the fractions as is. If the denominators are different, we can't add as is. We have some steps before we can add. So for number 1, we have unlike denominators, different denominators. We have a 5 and a 10. That means we need to find a common denominator. That's our first step. Then we rename the fractions with that common denominator. After we rename, we can add the fractions. That's going to give us our answer. And then lastly, we can simplify that answer if needed. So our first step here is to find a common denominator between 5 and 10. Basically, this is just a common multiple between 5 and 10. A number, 5 and 10, both go into, so to speak. And to show you what I mean here, I'll write out the first 5 multiples of 5 and 10 to see if we have any multiples in common. The first 5 multiples of 5 are 5, 10, 15, 20, 25, and these continue on. The first 5 multiples of 10 are 10, 20, 30, 40, 50, and these continue on. So looking at our lists of multiples, do we have any in common? Yes, 10 and 20. And really, these will have an infinite number of common multiples. So what we want is the least common multiple. Now we can use any common multiple, but the least common multiple makes things simpler. That's going to be 10 here. So that's the common denominator that we are going to use. And more specifically, that's the least common denominator. So now we need to rename these fractions with that least common denominator of 10. Let's start by renaming 2/5. So we put our denominator of 10, and now we need to think, how do we get that denominator of 5 to equal 10? Well, 5 times 2 gives us 10. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. So we need to do 2 times 2, and that gives us our numerator of 4. So 4/10 is our renamed fraction, and this is an equivalent fraction. So we're not changing the value of anything here. Plus, and now we need to rename our other fraction, 1/10. Well, 1/10 already has that denominator of 10. So we actually don't need to rename here. 1/10 is fine. as is. Again, because we already have that denominator of 10. And now that we have a common denominator, we are able to add. So we add our numerators. 4 plus 1 gives us 5. And then we keep that denominator of 10 the same. So we end up with 5/10. And that's our answer. Now, once we have our answer, we can look to see if it can be simplified. Can 5/10 be simplified? Yes, we have a common factor other than 1 that we can divide both 5 and 10 by. We can divide by 5. So let's divide 5 by 5 and 10 by 5. 5 divided by 5 gives us 1, and 10 divided by 5 gives us 2. So we end up with 1/2. The only common factor between 1 and 2 is 1, so this is now in simplest form. Our simplified answer is 1/2. Let's move on to number 2, where we have 7/12 plus 3/8. Do we have a common denominator here? No, so we can't add these fractions as is. We need a common denominator. So we need a common multiple of 12 and 8, specifically the least common multiple. Let's try to do this one without writing out the multiples. So what's the least common multiple here? We can think, what number does both 12 and 8 go into? Now, I like to always start with the larger denominator and see if it will be our least common denominator, like how 10 was for number 1. 12 is our larger denominator here. So is 12 a common multiple of 12 and 8? No, 12 works for 12, but 12 doesn't work for 8. 12 is not a multiple of 8. So let's try the second multiple of 12 and see if that works. That's 24. Will 24 work? Yes, 24 works for 12. 12, 24, 36, and so on. So 24 is a multiple of 12. And yes, 24 works for 8 as well. 8, 16, 24, and so on. So 24 is a multiple of 8. 24 is our least common multiple between 12 and 8. Therefore, our least common denominator. So let's rename these fractions with that denominator of 24. We'll start with 7/12. So how do we get 12 to equal 24? 12 times 2 gives us 24. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. 7 times 2 gives us a numerator of 14. So we get 14/24 plus, and now let's rename 3/8. How do we get 8 to equal 24? 8 times 3 gives us 24. So we need to do that to the numerator as well, multiply by 3. 3 times 3 gives us a numerator of 9. So 9/24. And now we have both fractions renamed with that common denominator, that least common denominator of 24. And now we can add. So let's add the numerators. 14 plus 9 gives us 23. And then we keep that denominator of 24 the same. So we end up with 23/24. Now, can we simplify this fraction? No. The only common factor between 23 and 24 is 1. So this is already in simplest form. We are done. Our answer, 23/24. So there's how to add fractions with unlike denominators. Let's move on to subtraction. Here's our section on subtracting fractions with unlike denominators. Now we're going to use the same steps as we did with adding, but instead of adding, we subtract. Let's jump into number 1, where we have 3/4 minus 5/12. So our first step here is to find a common denominator between 4 and 12. Basically, this is just a common multiple between 4 and 12. We can think of it as a number that both 4 and 12 go into, so to speak. And to show you what I mean, I'll write out the first 5 multiples of 4 and the first 5 multiples of 12. The first 5 multiples of 4 are 4, 8, 12, 16, 20, and these continue on. The first 5 multiples of 12 are 12, 24, 36, 48, 60, and these continue on. So do we have any common multiples here? Any multiples that 4 and 12 share? Yes, 12. And really, multiples continue on forever. They are infinite. So we're going to have an infinite number of common multiples. So what we want is the least common multiple. Now we can use any common multiple, but the least common multiple makes things simpler. And that is 12 here. So that's our common denominator. And more specifically, our least common denominator. So now we need to rename these fractions with that least common denominator of 12. We'll start by renaming 3/4. So we will put our denominator of 12 here, and we need to think, how do we get 4 to equal 12? Well, 4 times 3 gives us 12. Whatever we do to the denominator, we must do to the numerator in order to keep this equivalent. 3 times 3 gives us a numerator of 9. So we have 9/12. And this is an equivalent fraction. We're not changing the value of anything here. Minus, and now we need to rename 5/12. But notice 5/12 already has that denominator of 12. So we don't need to rename. 5/12 is fine as is. And now that we have a common denominator here, we can subtract. So we subtract the numerators. We have 9 minus 5. That gives us 4. And then we keep that denominator of 12. So we end up with 4/12. And that's our answer. But 4/12 can be simplified. We have common factors other than 1 that we can divide both 4 and 12 by. The greatest common factor is 4. So let's divide both 4 and 12 by 4 in order to simplify. 4 divided by 4 gives us 1, and 12 divided by 4 gives us 3. So we end up with 1/3. The only common factor between 1 and 3 is 1. So this is now simplified. Our final simplified answer, 1/3. Let's move on to number 2, where we have 4/9 minus 1/6. Do we have a common denominator? No, so we can't subtract these fractions as is. We need a common denominator. So we need to look for a common multiple of 9 and 6, specifically the least common multiple. Now let's try to do this one without writing out the multiples. So what's the least common multiple here? We can think, what number will both 9 and 6 go into? Now, I like to always start with the larger denominator and see if it will be our least common denominator, like how 12 was our least common denominator for number 1. 9 is our larger denominator here. Is 9 a common multiple of 9 and 6? No, 9 works for 9, but 9 doesn't work for 6. 9 is not a multiple of 6. So let's try the second multiple of 9. That's 18. So will 18 work? Yes, 18 works for 9, 9, 18, 27, and so on. So 18 is a multiple of 9. And yes, 18 works for 6 as well. 6, 12, 18, so on and so forth. So 18 works for 6. So 18 is the least common multiple between 9 and 6. Therefore, our least common denominator. So now we need to rename these fractions with that least common denominator of 18. Let's start with 4/9. So how do we get 9 to equal 18? Well, 9 times 2 gives us 18. That means we need to multiply the numerator by 2 as well. 4 times 2 gives us 8. So we get 8/18 minus, and now let's rename 1/6. How do we get 6 to equal 18? Well, 6 times 3 gives us 18. That means we need to multiply the numerator by 3 as well. 1 times 3 gives us 3, so we get 3/18. And now we subtract. So subtract the numerators. 8 minus 3 gives us 5. And then we keep that denominator of 18. So we end up with 5/18. Now the only common factor between 5 and 18 is 1. So this is in simplest form. Our final answer, 5/18. So there's how to add and subtract fractions. Let's move on to multiplication. Here's our section on multiplying fractions. We'll start with multiplying a fraction by a fraction, move on to multiplying fractions and whole numbers. Then we'll take a look at a strategy called cross-cancellation that we can use when multiplying fractions. So starting with multiplying two fractions, let's jump into number 1, where we have 1/2 times 3/4. Now when we multiply fractions, all we need to do is multiply straight across. So multiply the numerators, the top numbers, and then multiply the denominators, the bottom numbers. That gives us our answer, and we can simplify that answer if needed. So for number 1, let's start by multiplying the numerators. 1 times 3 gives us 3. Now for the denominators, 2 times 4 gives us 8. That gives us our answer, 3/8. Now the only common factor between 3 and 8 is 1, so this is in simplest form. We are done here. Our final answer, 3/8. Let's move on to number 2, where we have 7/8 times 2/3. Let's multiply straight across, starting with the numerators. 7 times 2 gives us 14. And now for the denominators. 8 times 3 gives us 24. So we end up with 14/24. Now 14/24 can be simplified. We have a greatest common factor of 2 that we can divide. 14 and 24 by. 14 divided by 2 gives us 7, and 24 divided by 2 gives us 12. The only common factor between 7 and 12 is 1. So this is in simplest form now. Our final simplified answer, 7/12. Moving on to number 3, we have 5/12 times 2/5. Let's multiply the numerators. 5 times 2 gives us 10. Now for the denominators, 12 times 5 gives us 60. So we end up with 10/60. And that's our answer. But 10/60 can be simplified. We have common factors of 10 and 60 other than 1 that we can divide by here. Now the greatest common factor is 10. So let's divide 10 by 10 and 60 by 10. 10 divided by 10 gives us 1, and 60 divided by 10 gives us 6. So we end up with 1/6. The only common factor between 1 and 6 is 1, so this is now in simplest form. So again, our answer here, 1/6. Lastly, let's move on to number 4, where we have 4/5 times 4/5. So multiplying the numerators, we have 4 times 4. That gives us 16. And now for the denominators, 5 times 5 gives us 25. So we end up with 16/25. The only common factor between 16 and 25 is 1. So this is in simplest form. We are done. Our final answer, 16/25. So there you have it. There's how to multiply two fractions. Let's move on to multiplying fractions and whole numbers. So here's our section on multiplying fractions and whole numbers. Now remember, when we multiply fractions, all we need to do is multiply straight across. We do the same thing when we have a whole number involved. We just have one little extra step before we multiply. We start by rewriting the whole number in fractional form. And we do that by putting it over 1. So we rewrite the whole number in fractional form. Then we multiply straight across. That will give us our answer. And we can simplify that answer if needed. Let's jump into number 1, where we have 3 times 3/4. So let's rewrite our whole number in fractional form by putting it over 1. So 3 over 1 times 3/4. That's still 3. We still have a value of 3 there. So we're not changing the value of anything. We want this in fractional form, so we have a numerator and a denominator. That way we can multiply straight across. So now let's multiply straight across, starting with the numerators. So we have 3 times 3. That gives us 9. And for the denominators, we have 1 times 4. That gives us 4. And we end up with 9/4, which is our answer. But it's an improper fraction, so let's convert this to a mixed number. And remember, we convert improper fractions to mixed numbers by dividing the numerator by the denominator. So we need to do 9 divided by 4. So how many groups of 4 in 9? Well, 2. 2 whole groups of 4 in 9. That's our whole number of our mixed number. That gets us to 8. So we have a remainder of 1. That's the numerator of our fractional part of the mixed number. And then we keep that denominator of 4 the same. So we end up with 2 and 1/4. Now we can always look to simplify the fractional part of a mixed number, but 1/4 is in simplest form. The only common factor between 1 and 4 is 1. So we are done here. Our final answer, 2 and 1/4. Now to go back to the improper fraction to mixed number, I'm going to write that out to make it a little more clear here. So we did 9 divided by 4. So how many groups of 4 in 9? Well, 2. That gets us to 8. So multiply now. 2 times 4 is 8. Subtract, we get a remainder of 1. 2 is our whole number right here. And then that remainder of 1 is the numerator of our fractional part. Then we keep that denominator of 4 the same. Now, you may have noticed our answer is less than the whole number we started with, 3. That's because when we multiply by something less than 1, we get a smaller result. We end up with part of the whole number we started with. So anytime we multiply a whole number by something less than 1, our answer will be less than the whole number we started with. So just something to keep in mind. Let's move on to number 2, where we have 5/8 times 7. So we need to rewrite this with our whole number in fractional form. So we put 7 over 1. Now we can multiply straight across, and we'll start with the numerators. 5 times 7 gives us 35. And for the denominators now, 8 times 1 gives us 8. So we end up with 35/8, which is an improper fraction. Let's convert this to a mixed number. So we need to do 35 divided by 8. How many groups of 8 in 35? Well, 4. That gets us to 32. So we have a remainder of 3, and then we keep that denominator of 8 the same. So we end up with 4 and 3/8. Let's see if we can simplify the fractional part of the mixed number. 3/8 is in simplest form. The only common factor between 3 and 8 is 1. So we are done here. Our final answer, 4 and 3/8. Let's move on to number 3, where we have 8 times 1/6. So let's rewrite our whole number in fractional form. And now we can multiply straight across. We'll start with the numerators. 8 times 1 is 8. And then for the denominators, 1 times 6 is 6. So we end up with 8/6, which is an improper fraction. So let's convert this to a mixed number. We need to do 8 divided by 6. How many groups of 6 in 8? Well, 1. That gets us to 6. We have a remainder of 2. And then we keep that denominator of 6 the same. So we get 1 and 2/6. Now, 2/6 can be simplified. We have a greatest common factor of 2 that we can divide 2 and 6 by. Now, when we simplify that fractional part, we don't do anything with the whole number. The whole number stays the same. So we have 1, and then 2 divided by 2 gives us 1, and 6 divided by 2 gives us 3. The only common factor between 1 and 3 is 1, so this is now simplified. Our final simplified answer, 1 and 1/3. Lastly, let's move on to number 4, where we have 2/5 times 15. So let's rewrite our whole number in fractional form here. And now we can multiply straight across. We'll start with the numerators. 2 times 15 gives us 30. And then for the denominators, 5 times 1 gives us 5. So we end up with 30/5, which is an improper fraction. So let's convert this to a mixed number. We need to do 30 divided by 5. And 30 divided by 5 gives us 6. We hit 30 exactly. We do not have a remainder here, so we don't have a fractional part of our mixed number. This is just going to be a whole number. 6 is our final answer. So there you have it. There's how to multiply fractions and whole numbers. Now let's take a look at cross-cancellation. Now, in our last section here, we're going to look at multiplying fractions using cross-cancellation. This is a strategy we can use to basically simplify a problem before we multiply. This gives us smaller numbers to work with, which can make things easier for us. Now, do we have to use cross-cancellation? No, we can always just multiply straight across, but this is a helpful strategy to be familiar with. Let's jump into number 1, where we have 8/15 times 5/12. Let's see if we can use cross-cancellation here. We do this by looking for common factors diagonally. Think of this like simplifying fractions, but we are looking diagonally. So we'll start with 8 and 12. Do we have any common factors other than 1 that we can divide these by? Yes, and the greatest common factor is 4. So let's divide both 8 and 12 by 4. Let's start with 8. 8 divided by 4 is 2. So we cross out 8, and now we have 2. Now we do 12 divided by 4. 12 divided by 4 is 3. So we cross out 12, and now we have 3. So we cross-canceled there using a common factor. And now we have smaller numbers to work with. Now, can we multiply straight across at this point? Yes, but let's look at the other diagonal. So 15 and 5. Do we have any common factors other than 1 that we can divide by here? Yes, we have a greatest common factor of 5. So let's divide 15 and 5 by 5. We'll start with 15. So 15 divided by 5 is 3. We cross 15 out, and now we have 3. Now for 5. 5 divided by 5 is 1. So we cross 5 out, and now we have 1. Now let's multiply straight across. So numerator times numerator and denominator times denominator. We'll start with the numerators. 2 times 1 gives us 2. Now for the denominators. 3 times 3 gives us 9. And we end up with 2/9. And that's our answer. The only common factor between 2 and 9 is 1, so this is in simplest form. We are done here. Final answer, 2/9. Now this problem worked out really well for cross-cancellation, but keep in mind, some problems we won't be able to use cross-cancellation because we won't have any common factors other than 1 to divide by. And then some problems we may be able to use cross-cancellation on only one of the diagonals. And then some problems will be like this, where we can use cross-cancellation on both diagonals. So cross-cancellation completely depends on the fractions we are working with. Now, before moving on to number 2, let's see what this problem looks like if we multiply straight across. So let's rewrite this down below. So 8/15 times 5/12. And let's multiply straight across. 8 times 5 gives us 40. And then 15 times 12 gives us 180. So we get 40 180ths. So this looks different than our answer above, but we can simplify here. We have common factors other than 1 that we can divide by. The greatest common factor is 20. So let's divide 40 by 20 and 180 by 20. 40 divided by 20 gives us 2, and 180 divided by 20 gives us 9. So we end up with 2/9 that way as well. So we can see that cross-cancellation gives us the opportunity to simplify before multiplying. And this can give us smaller numbers to work with. Let's move on to number 2, where we have 14 times 7/8. Let's rewrite our whole number in fractional form. So we have a numerator and a denominator. So 14 over 1 times 7/8. Now let's see if we can use cross-cancellation. So looking diagonally, let's start with 14 and 8. So do we have any common factors other than 1 between 14 and 8? Yes, we have a greatest common factor of 2. So let's divide 14 and 8 by 2, starting with 14. 14 divided by 2 gives us 7. 8 divided by 2 gives us 4. Now, as far as the other diagonal, we have 1 and 7. Do we have any common factors other than 1 here? No. So we can't cross-cancel here. We can't break these down any further. So now let's multiply straight across, starting with the numerators. 7 times 7 gives us 49. And as far as the denominators, 1 times 4 gives us 4. So we end up with 49/4, which is an improper fraction. So let's convert this to a mixed number. We need to do 49 divided by 4. So how many groups of 4 in 49? Well, 12. That gets us to 48. So again, 49 divided by 4 is 12. And that gets us to 48. So we have a remainder of 1. That's our numerator. And we keep that denominator of 4 the same. So we end up with 12 and 1/4. Now the fractional part here, 1/4, is in simplest form. So we are done. Final answer, 12 and 1/4. Now let's multiply straight across and see what we get. So 14 over 1 times 7/8. We'll start with the numerators. We have 14 times 7. That gives us 98 over, and then the denominators here, 1 times 8 gives us 8. And we end up with 98/8, which is an improper fraction. So let's convert this to a mixed number. We need to do 98 divided by 8. So how many groups of 8 in 98? Well, 12. That gets us to 96. So again, 12 groups of 8 in 98. That gets us to 96. So we have a remainder of 2, and we keep that denominator of 8 the same. So we end up with 12 and 2/8, which is different than our answer above, 12 and 1/4. That's because 2/8 can be simplified. We have a greatest common factor of 2 that we can divide 2 and 8 by. So we end up with 12, and then 2 divided by 2 is 1, and 8 divided by 2 is 4. So we end up with 12 and 1/4 that way as well. So there's how to use cross-cancellation. Again, is this something we have to use? No, but it can be a helpful tool. So it's something to keep in mind whenever we have multiplication problems involving fractions. So there's how to multiply fractions. Let's move on to division. So here's our section on dividing fractions. We'll go through dividing fractions by fractions, dividing whole numbers by fractions, and dividing fractions by whole numbers. We'll start with dividing a fraction by a fraction. Let's jump into number 1, where we have 5/6 divided by 1/4. So basically, we're figuring out how many groups of 1/4 we can make from 5/6. Or, in other words, how many 1/4 are in 5/6. Now, whenever we have a division problem involving fractions, we have 3 steps. Keep, switch, flip. We're actually going to rewrite the division problem as a multiplication problem. So when we rewrite this, we keep our first fraction. We keep 5/6 as is. Then we switch to the inverse or opposite of division, which is multiplication. So we switch to multiplication. And since we switched to the inverse of division, we need to flip our second fraction. So the numerator, 1, is now the denominator, and the denominator, 4, is now the numerator. So 4 is now the numerator, and 1 is now the denominator. When we flip a fraction like this is called the reciprocal. So when we rewrite this and keep, switch, flip, we're multiplying by the reciprocal. And now all we need to do is multiply straight across. So numerator times numerator and denominator times denominator. Let's start with the numerators. 5 times 4 gives us 20. Now for the denominators, 6 times 1 gives us 6. So we end up with 20/6, which is an improper fraction. So let's convert this to a mixed number. Remember, we do this by dividing the numerator, 20, by the denominator, 6. So 20 divided by 6. How many groups of 6 in 20? Well, 3 whole groups of 6 in 20. That gets us to 18. So we have a remainder of 2. That's our numerator of the fractional part. And then we keep that denominator of 6 the same. So we end up with 3 and 2/6. And that's our mixed number. Now 2/6 can be simplified. We have a common factor other than 1 here that we can divide 2 and 6 by. We have a greatest common factor of 2. So let's divide 2 by 2 and 6 by 2 in order to simplify. We keep our whole number of 3 the same, and then 2 divided by 2 gives us 1, and then 6 divided by 2 gives us 3. The only common factor between 1 and 3 is 1. So this is now in simplest form. Our final simplified mixed number, 3 and 1/3. Let's move on to number 2, where we have 3/8 divided by 2/5. So we keep, switch, and then flip. So 2 is now the denominator, and 5 is now the numerator. And now we can multiply straight across. 3 times 5 gives us 15, and then 8 times 2 gives us 16. So we end up with 15/16, which is a proper fraction here, and the only common factor between 15 and 16 is 1. So this is in simplest form. We are done. Final answer, 15/16. So just remember, when we have division problems involving fractions, we keep, switch, flip, which in other words, we are multiplying by the reciprocal. Let's move on to dividing whole numbers by fractions. Now we'll take a look at how to divide a whole number by a fraction. Let's jump into number 1, where we have 3 divided by 1/2. So basically, we are figuring out how many groups of 1/2 we can make from 3. Or in other words, how many halves are in 3. So let's rewrite this problem using keep, switch, flip, starting with keep. In this case, we have a whole number, 3. So when rewriting this problem, we keep 3, but we are going to write it in fractional form. That way, we have a numerator and a denominator. And remember, we can write whole numbers in fractional form by putting them over 1. And then after we keep whatever comes first, we switch to the inverse of division, the opposite of division, which is multiplication. So let's switch to multiplication here. And since we switched to the inverse of division, we need to flip whatever comes second. In this case, it's a fraction, 1/2. So let's flip 1/2. The numerator, 1, is now the denominator. And then the denominator, 2, is now the numerator. So we have 2 over 1. And now all we need to do is multiply straight across. Let's start with the numerators. 3 times 2 gives us 6. And then for the denominators, 1 times 1 gives us 1. So we end up with 6 over 1, which is just 6. And this is our final answer. 3 divided by 1/2 equals 6. And think about it. If we start with 3 wholes, let's use 3 whole sandwiches, for example, something we can picture, and we divide each sandwich in half, how many halves does that give us? 6. Let's move on to number 2, where we have 8 divided by 3/4. So keep, switch, flip. So let's keep 8. And we're going to write it in fractional form. That way we have a numerator and a denominator. So keep, switch, and now we need to flip 3/4. So 3 is now the denominator, and 4 is now the numerator. And now we can multiply straight across. Let's start with the numerators. 8 times 4 gives us 32. Now for the denominators, 1 times 3 gives us 3. So we end up with 32/3. And that's our answer. But we have an improper fraction here. So let's convert it to a mixed number by dividing the numerator by the denominator. So 32 divided by 3. How many groups of 3 in 32? Well, 10. That gets us to 30. So 10 whole groups of 3 in 32. Again, that gets us to 30. So we have a remainder of 2. That's the numerator of our fractional part. And then we keep that denominator of 3 the same. So we end up with 10 and 2/3. We can always look to simplify the fractional part of a mixed number. The only common factor between 2 and 3 is 1. So this is in simplest form. Our final answer, 10 and 2/3. So there you have it. There's how to divide a whole number by a fraction. Let's move on to dividing fractions by whole numbers. Now we'll take a look at how to divide a fraction by a whole number. Let's jump into number 1, where we have 1/4 divided by 2. So basically, we are taking 1/4 and dividing it into two equal groups, two equal parts. So let's rewrite this problem using keep, switch, flip, starting with keep. So we keep our first fraction here, 1/4. So keep 1/4 as is. And then we switch to multiplication. Then we flip. But we have a whole number here. So how do we flip that whole number? Well, we need to write our whole number in fractional form. And we do that by writing it over 1. So we put 2 over 1, and now 2 is in fractional form. And we flip this fraction. So 2 is now the denominator, and 1 is now the numerator. And now all we need to do is multiply straight across. We'll start with the numerators. 1 times 1 gives us 1. And then for the denominators, 4 times 2 gives us 8. And that's our answer, 1/8. The only common factor between 1 and 8 is 1, so this is in simplest form. We are done. 1/4 divided by 2 equals 1/8. Let's move on to number 2, where we have 4/5 divided by 6. Let's keep, switch, and now we need to flip 6. So we write it in fractional form by putting it over 1. And 6 is now the denominator, and 1 is now the numerator. Now we can multiply straight across. For the numerators, we have 4 times 1. That gives us 4. And then for the denominators, we have 5 times 6. That gives us 30. So we end up with 4/30, which this can be simplified. We have a greatest common factor of 2 that we can divide 4 and 30 by. 4 divided by 2 gives us 2, and 30 divided by 2 gives us 15. So we end up with 2/15. The only common factor between 2 and 15 is 1, so this is now in simplest form. Our final answer, 2/15. So there you have it. There's our complete step-by-step course on fractions. I hope that helped. Thanks so much for watching. Until next time, peace.